Hello, my name is Dr. Nat Martin. I'm the Principal Product Owner for the LiveID software. I'm going to give you a quick demo of the new library matching workflow we have introduced in version 2.0 of LiveID, which is to coincide with the release of the new Radian ASAP instrument. The new workflow complements the existing multivariate statistical workflows we continue to support in LiveID. LiveID version 2 also brings with it the ability to import and export models, opening up the ability for researchers to share their analytical techniques and results with their co-workers. I'm going to introduce the principles of library matching and then show you how easy it is to perform in LiveID. When we analyse pure samples using the Radian ASAP, they ionise and fragment in a predictable way, generating a spectral fingerprint. These fingerprints depend on the energy used to generate them, and by varying the energy applied by the Radian ASAP, we can generate multiple fingerprints simultaneously. By using multiple fingerprints for the same compound, we can get a much higher confidence in the match score. Spectral fingerprints of compounds of interest can be added to a library, and LiveID can then compare them to new samples where information about the presence or absence of these compounds is desired. LiveID generates a match score out of 1,000, where values close to 1,000 indicate it is likely the compound of interest is in the sample. Lower scores indicate it is unlikely to be present in the sample. I will show you how to create a library matching project and perform our first library match. The first thing to do is to create a new project and enable library matching. This project will store the results we produce. We need to select the correct data type for the Radian ASAP, which is QDA, and enable library matching. We then need to load the library we're going to use, and I click the Load Library button. I then simply select a library that contains the compounds I'm interested in today. LiveID will confirm the library is successfully loaded. I then proceed to library matching. I will show you in a minute a video clip of real-time library matching which nicely illustrates the power of the LiveID MassLynx Radian ASAP system. First, I will show you an offline library match on a pre-acquired file. We click the offline library match and select the file we wish to analyse. Users could then optionally change the suggested threshold and parameters or proceed directly to library matching. The threshold sets which sample scans are included in the match, and the advanced parameters allow you to tailor the matching algorithm to your particular use case. When we hit match, LiveID matches the library against each sampling region and calculates the score for every compound in the library. A cutoff value filters out compounds which do not match well. In this sample, we only have one compound that matches well. You can step through the sampling regions and see the scores for each one in turn. The top to tail plots show the scores at the different energies, adding confidence to the match result. A PDF report can be generated, which details all of the scores and details of the library match. Here is real-time library matching with LiveID in action. MassLynx and LiveID are primed and waiting for the sample to be introduced to the instrument. When the analyst places the sample holder on the instrument, acquisition begins and LiveID starts recording the scan data. The instant the sample is introduced, the compounds begin ionizing and fragmenting. LiveID will start combining the data, ready to perform a match. When the sampling event is over, LiveID quickly matches all compounds in the library against it and presents the results to the user. In this case, we have detected one compound in the sample with a high match score. Subsequent samples can be introduced and LiveID will continue to match them against the library. At the end of the session, the results can be viewed and a PDF created as for offline library matching. Radian ASAP with LiveID, the power of knowing now.